We are going to study binomial theorem. Binomial basically means two. So it is a theorem to expand an expression of the form a plus b to the power n, where a and b can be complex number. Complex number includes real numbers, natural numbers, whole numbers, and everything. And n is an integer. So the formula says a plus b to the power n equal to nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power n plus nc2 a to the power n minus 2 b to the power 2. And all the way, the last term will be ncn a to the power n minus n, which is 0, and b to the power n. If you look at the formula, we can see there is a pattern. You can look at this nc2 a to the power n minus 2 b to the power 2. So this 2 here is same as the 2 raised for b, and this 2 is also same as this 2 here. So using this pattern, we can write the generic term, which is n c r a to the power n minus r b to the power r. And if we observe the formula pattern again, we can see the first term, this is 0, the second term, this is 1, and the third term, this is 2. Okay. So since this is r, we can say this is the term r plus 1. We can write the formula in the summation notation as well, where a plus b to the power n can be written as ncr a to the power n minus r b to the power r, where r ranges from 0 to n. This is basically the binomial theorem. Before we go further, I want to explain what this NCR means. NCR equals to number of ways of choosing R distinct objects from N distinct objects. And NCR is equal to N factorial divided by R factorial into N minus R factorial. And N, which is equal to N C N minus R. Okay, this is our generic formula, and we use this to calculate what is a minus b to the power n. Then second, what is 1 plus x to the power n, and third, what is 2. So we take the first one, a minus b to the power. Okay, let's try a minus b to the power n. So we replace b with minus b. So a minus b to the power n will become nc0 a to the power n minus b to the power 0 plus nc1 a to the power n minus 1 minus b to the power 1 plus nc2 a to the power n minus 2 minus b to the power of 2, and so on. So here what we see is minus b can be raised to the power 0, 2, 4, 6, which is even numbers, and minus b can also be raised to the power 1, 3, 5, which is odd number. So this expression will become nc0 a to the power n minus nc1 a to the power n minus 1 b plus nc0 a to the power n minus 2 b square minus nc3 a to the power n minus 3 b cube. So wherever it's odd, it will be a minus term. Wherever it's even, it will be a positive term all the way. Let's take the second one, which is 1 plus x to the power n. So we replace a with 1 and we replace b with x. So 1 plus x to the power n will be n c 0 1 to the power n x to the power 0 plus nc1 1 to the power n minus 1 x to the power 1. Since 1 to the power of any integer is always equal to 1, so I will skip writing this in the next few terms. Plus nc2 x to the power 2 plus nc3 x to the power cube all the way up to ncn x to the power n, which is nc0 x to the power, right, nc0x which is equal to nc0 plus nc1 x plus nc2 x square plus ncn x to the power n. Similarly, we can do 2 to the power n. Here we can take a is equal to 1 and b is equal to 1. So 2 to the power n, which is 1 plus 1 to the power n, can be written as nc0 1 to the power n 1 to the power 0 plus nc1 1 to the power n minus 1 1 to the power 1 plus I will skip writing 1 to the power because it's always equal to 1. nc2 plus nc3 plus ncn. So 2 to the power n is equal to NC0 plus NC1 plus NC2 NCN.